Hello UniPlot community. This is the second part of our joint Virtual Dynamic and UniPlot webinar. Learn how to add value to your NVH data and make report out of them.
In the next segment, Adrian will demonstrate the advanced functionality where he has received input from such a complex model as seen here. This is a two-stage electric drive unit consisting of flexible e-motor housing, gear housing, shafts with roller bearings, e-motor, revenue planetary gear sets. I will now hand over the session to Adrian, who will take you through the advanced functionality. Over to you, Adrian.
Thank you, Prashant, for this view of the world of UniPlot for Virtual Dynamic. I am sure you wonder why you should use UniPlot instead of Virtual Dynamic Embedded Processor. Well, I will now share with you some more advanced functionalities UniPlot offers, and you will see why by yourself. I will first show you how to transform your data using data filter and how to create new data set out of it. Then we will focus on possibilities UniPlot has to make a professional report out of your analysis. And in a second part, I will present UniPlot Sequencer, which is a great feature to make your workflow fully automatic and avoid repetitive tasks. You now know the UniPlot interface, so I will directly jump in and create a simple example for you to show you those advanced features. I will create a 2D XY diagram with the time in X and some other data on Y. Just let me find the correct channel. And I will, let's say, take this one and I will plot it. Okay, we have our curve. I used the default option Prashant showed earlier to already set the colors that I like to work with. So I will start to copy paste the curve and let's apply some modification on the curve. All you can do on your curve is shown in the append filter function. Not enter into much detail here, but you can see that there's a wide list and you can add your own function to it. For this example, I will extract a part of the curve. I will put some data here. Okay, and we don't see anything, and that's normal. I will change the color of the curve so that you can see what I'm doing. Okay, so you can see first a quick extract. I will now create another diagram and copy that in this new diagram and rescale. So we have the part of the curve that is interesting for us. I will show you that in 2 clicks we can create an FFT of this curve. Up, I can use specific windows and number of segment points. For the moment, I will leave everything in default and rescale. Let's put a meaningful title. Okay, but doing an FFT is one thing, but having meaningful information out of it is another thing. To do that, I will use another functionality. First, we modify the curve. Here with new dataset, we're adding another layer on the top. I will use the find peak function. Here, you give some information on how to find the peaks or the valley, by the way, if that's interesting for you, and click on OK. And you can see that my curve was modified a little bit with those 2 points detected. So one peak at 2 Hertz, and then another one a little bit before 1000 Hertz. Again, it's just visual. I want to do something out of it. Let's right click on it. And now another new menu, text object. I will add a 2D table on top. And now you can see that this table has been created with the information of the peaks of my FFT spectrum. Okay, good. Not good enough for me. I want one more thing. The idea, as Prashant said, is to analyze maybe several tests and to keep one template that you will reuse several times. So it would be good if the template would inform you, let's say, whether the frequency of this peak goes above 900 Hertz. You can then add conditional formatting. I will do that here. And I will say, okay, whenever I am above 900, I will have a red cell, please. Okay, and I even change the font color if I want. I click on OK. And right now, of course, it goes to 900. If I were to exchange the data file and put something with another frequency, then automatically the table would have the color based on the value of the frequency. Now I'm going to make report. We want to show things, transmit an information to the reader. So we can draw, of course. Here, let me put an arrow to that peak. Let's put a small box to really highlight that peak, and we can do more things. Let's say I want to put some rectangle, solid color, let's say PA green, and a bit of transparency to see my curve. Okay, and now this could be included to show a specific issue in a signal analysis for your reader. It's yeah, now your job to work with that and let your feelings talk. Now I will add some more information on this curve, because sometimes you see the curve, but you want to provide more information. So I will right click on the axe and use the threshold value option. And here you can add either a single line or a range as a threshold. Give the color you want. As always in UniPlot, it's the constant. And you can have it horizontal or vertical. In this case, I will ask it horizontal and click on OK. And here you can see that I have my threshold that has been updated. By the way, my axe is automatically updated to the latest color of the dataset. This behavior can be changed, updated, adapted as you like. And then there was an introduction of patient regarding formulas, and I would like to go one step further with that. Let me find one I created for this webinar. Okay, this one. I will right click and show you the kind of formula you can write. So you can do arithmetic computation, but you can go one step further with multi-line formula with intermediate variable. And here, for example, based on the two component of reaction force, I can use the arctangent 2 function and compute the angle of the resulting force. And that's not all. If you look into the function menu, you can see a lot of functions. You can do integrals, derivative, as shown. You can use conditional functions like compare information. You can do if then else statement to get the information you need. And if you have a doubt, you contact us and we can guide you to create the perfect formula for your case. Now, that was a simple example. Let me now switch to another template. Let me open that right now. Okay, that's the one. So let's start with the main page. Up to now, we saw one page. Now I will go one step further with the full template that could be used for an analysis. Here, as an example, I have a main page that would be the landing page of my project, where you can put picture, they can be embedded or linked. You can have table with automatic information filled in. That's pretty useful to work with. So for example, here, there is what is called field function, and there is a lot of those, which will automatically take the initials of the person creating the report. To access them, right click, add field function. And here you can see the example of information you can have, like summary info, the time, alias. I let you discover them. You can get more information thanks to the help button. By the way, UniPlot documentation is a mine of information. Do not hesitate to dive in and you'll get everything you need there. Okay, so that was my main page. I will now switch to the second page. Here, I will analyze the bearings and the forces that are acting on the rotor shaft bearings. Here we can see X and Y forces for bearing 1 and bearing 2. And for bearing 1, we also have the Z force. And there's this element on the right that is a highlight of UniPlot that I will show you right now. When you click on the cursor here on the top, you have this window that appears with all the data plotted in your diagram, the values at cursor 1 and 2 position, the delta between both cursors, and then a set of functionality that can be interesting for you, the maximum peak-to-peak value, standard deviation, area under the curve, etc. And you can add more if you want. So in this case, right now, we can see that when I move the cursor data, the table on the right is being updated. And we can see some red here. So let me just go here. It's showing me the maximum peak-to-peak value between the cursor. And before the webinar, I added a conditional format to this cell to tell me whenever I go above a given level, which I do not remember, but whatever. If I move the cursor a little bit, you can see that, okay, I am above this. So let's quickly check what I set. I said, okay, when it's greater than 900, so it will be red. So whenever you will switch your data, if the cursors are properly placed, you will have in a really quick manner the information on maximum peak-to-peak value and whether you exceed a threshold that you can define. And here I limited the table to just peak-to-peak, but with a simple click, you can decide to add more information to this table. Then FFTs, again, another example. So we already saw in the first example that we can create easily FFTs. So I repeated that and I show you an example in a proper report with all my curves and the FFT for each data set that we see here on the left. And by the way, here I used an automatic legend. So whenever I add or remove curves in the diagram, it will be shown here. Another page. Okay, orbital plot. We had an introduction with Prashant. Now, what can we do with that? Here we are going to analyze the forces that are acted on the shaft 1 bearings. So we have 2 bearings, bearing 1 and bearing 2. And what did I plot? On the lower part with negative value, we have the component on X and Y of those forces for bearing 1 and bearing 2. And then I computed the norm using a formula. So here we can see the norm. By the way, another feature you have in UniPlot, a magnifying diagram. If your eyes are like mine, not so good, and you need to highlight something without scaling the whole diagram, you can use this feature, which is a little box here that you can modify, and then it will show you what you want here. Or it's a good way in a report to have the full scale diagram and show just the part you're interested in. Back to my norms. An interesting thing to know when you have a force on a bearing is to know the orientation of this one at the maximum amplitude. So on the right, I took the magenta curve and plotted it in an orbital diagram, plus the angle that was also computed as I have shown you with respect to the X and Y component. So I know that over all my tests, the forces are mostly along the minus 110 degree angle. So it will help me design my bearing by putting maybe the oil inlet at 90 degrees and this kind of information you would be interested in to check your bearings, okay? Or maybe check the wear in this position to be sure that, okay, it's the place where really the wear would be the worst and be sure that everything is all right. And I have done that for bearing 1 and 2. Let's go now for the displacement. For the displacement, I have done more or less the same with component on X and Y of the displacement, the norm and the angle. Here, the only extra feature I have added is the peak detection, which is this small point here at the top, and I have the maximum displacement and the angle. By the way, remember what we have seen just earlier, there is a correspondence between the force and the displacement angle. So that's an interesting thing to see, that the simulation in virtual dynamic is working fine. And also, as I explained you can put conditional formatting in your table to check for a maximum clearance in the bearing and be sure everything is correct. I will now switch to my latest slide of data. Here we have the tangential force between the shaft 9 and shaft 11 via gear 2 and 1. Bit too much detail here maybe. We have the force, the respective angular velocity of each shaft. Okay, here it's just an information, not something crazy, but on the right, I have a placeholder for 3D FFT. And if I do not run out of time, I will show you that at the end. You saw along all the pages that I have those information on the top, like on the main page, but differently from the main one. Here I cannot touch them. They're like embedded in the page. And the same for the page below, an automatic page number. This is done thanks to the background page. If I go to the background, you can see that I have these things that I can move. Let's put this one here. And you can see that it moves this way. It's a great way to have a common background for all the pages. And you can have several in case you have different page format. You can do as many background pages as you want and apply them respectively to the page you're interested in. And here I'm using the table. By the way, you can change colors, font, etc. In the table. And again, I'm using this kind of field function to get information. Here I have the name of the file I am working on. Okay, so now you have a professional report. But again, I'd like to go one step further. I will now present you the sequencer. It's UniPlot new feature to create, manage, and control workflows. Workflows are made of sequences and subsequences, I will show you, which hold a list of action each. All sequences and resources files belonging to a project get organized in a clean way in a project folder called Workspace. Let me show you that. I will go back to this workspace. Okay, so the sequencer is this tool, and you can open it via view sequencer. It's already here. Good. The workspace is related to a folder. Here, webinar virtual dynamic, simple. It's like a drawer. You can put templates, scripts, any information you want, data, picture, video, etc. for your sequence. It's a way to isolate it from the rest of your computer and to pass it from one person to another one. You will see it's really useful. How does it work? I will first create a sequence. My sequence, I leave it like this. And then, as I said, a sequence holds actions. So here is my sequence one. You can see the name. I will start to add actions. I will do a really simple run right now. I will select an action in the list, and you always have a small description here on the left. I will load the document. Here you can see that it's red. Why? Because if you go to the action description, the last window, you see that this parameter has to be filled in. And for the moment it's red. So everything is red, I cannot run it. So I will browse for a file. Here I will say, okay, let's load that. And by the way, the file can be in your workspace. You can give an absolute path or work with runtime value. I will show you after what it is about. And then let's do another step. I will export to PDF. Here everything is green, so it means by default it should be fine. And to run the sequence, you have to click on play, as easy as that. So let's see what happens. So the template has been loaded and PDF created, perfect. And I can see that here. It's empty, it's normal because I used the empty one. Okay, it was an example. Now let's switch to the full size example of sequencer usage. Here I will not save the change. I will close that and that, and that's all. Okay, so this one is called Webinar VD. If I go in there, I can see that I have much more information. I have data, I have a place to store my output, pictures that I might need, scripts, because I like to put them in some specific places, and all the templates I showed you earlier. I will put that aside. Okay, then I will now show you the sequences. So in this workspace, I have a main sequence and other sequences that I will explain afterward, but you can see that there is a small arrow next to it. It means they are used as subsections. So my main sequence, what does it do? I will just go step by step so that you see a little bit how it works. So there's this first button, which is reset all, because on the top here you have let's say, variable and objects that are being used and stored during the sequence execution. So it's always good to start with that to clean everything. Then I have extra functions. I am sure that in your company there is internal knowledge on how to compute specific things. You might want to create scripts for specific analysis, specific vibration post-treatment. So here, I personally do it this way. I register scripts here. And if I go here, let's say, for example, I can edit the script. And okay, a lot of things is happening here, but let's not enter into detail for the moment. Then runtime value, that's the next step for me usually. It's all the variable I will need during the analysis. Here, especially the mean time and max time, you will see I will use that to scale my diagram in the window of time I want, of RPM. And you can double click and modify that. So that's something like user input. Okay, what I will do, I will execute step by step by double clicking. So look, I will set the runtime value by double clicking here. Oh, and they are loaded. Perfect. Everything is going in the correct direction. Then I will load my data. I created a subsection to order a little bit. I'll go there. First, I will browse for a file. I'll do that right now. Always in my webinar VD workspace. And I will load this data. So this rec file. Here, everything seems to be okay. And then I will load the data. I double click here and you can see that this has become green. If I have more file, I can load a lot of file, okay, here. And then, and I can see which files are loaded by clicking here. Okay, this file has been loaded, good. And if I click on this button, can be useful, it's loaded on the data browser in case you want to check something. Let's go back. I have loaded my data. I will now load a template. Double click, template is loaded and empty, the one we used earlier. Then I will do the data exchange. So this is what Prashant told you. You have your template prepared and you inject some data in it. I double click, UniPlot does the magic, and okay, everything is here, not lying. Okay, good. Going back here, and then I will run this script, which will scale the data based on my runtime value. Just to show you, inside you see that my code is calling mean time and max time. So let's see what it does. I double click on it to execute it. And okay, it has been zoomed from 1500 to 3500. And the y-axis has been adapted, okay, to see it better. Because that's the idea, not only to zoom the x, but the y at the same time. Next step. Oh, deactivated. Cool feature of the sequencer. You decide to use or not specific section of the sequence because it depends on what you want to do. And I will show you here, no, right after. I will go to the export. So let's see what happens in the export. Again, a script that will let me decide what kind of export I want to do. So let's double click. Oh, I can choose PDF or PowerPoint. And by the way, this is fully adaptable. I will select PowerPoint here. And before that, I would like to show you that so that you see how the export to PowerPoint works. It's super cool and easy to use. So let me switch the screen. Okay, what you need is this slide with a square called UniPlot frame, another one UniPlot page title, and that's all. And UniPlot will know, okay, here I put the title, here I put the picture, and that's all. And then you can put whatever you want around that. So I click on OK, confirm that I selected PowerPoint export, and I click on OK. Now I will run the PDF export, and let's see what happens. Normally, I'll wait a little bit. Sorry, my bad. I forgot to run that before. And now it's exporting properly. And I will show you that it's on the other screen. Okay, and now everything has been exported properly to the PowerPoint page. And here I can say, oh, okay, this one we have a problem, so I leave the orange square and whatever. Okay, you have seen everything. Now, the idea is not to do that manually, of course, because we created a sequence. The idea is to run it automatically. So let's see what happens if I run the whole sequence. Okay, I'm asked for the data, of course. Let's take this one again. It will load the template. So first it's loading in memory the data. Okay, doing the data exchange, asking me where I want to export. Let's select PDF. Okay. And the PDF should be ready. And here we are. And I use that to show you one last feature. You see that the names might be a bit cryptic here. Well, that's because UniPlot is using the tab name to create this kind of architecture that I like. So here we have the main page, then bearings and gears. And for the bearings, we have the EMOT shaft 1 with the forces, and we can see the analysis and the FFT. For the shaft 1, the position, like the force and the displacement of the position. Sorry, position of the force and position of the displacement. So that's why we use this kind of naming. Okay. And so here we are. I showed you, everything I wanted to show you. Yeah, one more thing before we switch to the question and answer. Here is another example of what could be done and could be reached with a few more steps. So here, for example, we automatically detect maximum amplitude of vibration of your signal. And at this time, we take plus minus 0.1 second window and make an FFT to see which frequency is causing this amplitude at that time. So that would be one example. And then, okay, this one is a bit slow to load because there is a huge graph here that you will see where we executed 3D FFT of our signal, of the tangential force on the gear. And it's a good way to find eigenvalues. So here, it's the placeholder I told you about earlier. And to do that, I run my section. I gave some parameters to the functions. Okay, it can be as complex as you want, depending on the analysis you want to run, and get this kind of value. Okay, and of course, always we have the possibility to switch to the 3D view. But for the moment, I prefer the 2D one. And that would be all for the presentation. And I will then go back to the presentation so that we can start the Q&A of this webinar.
Well, thank you, Prashant, Adrian. That was a wonderful demonstration. And we can move on to the Q&A session. We still have some time left and already some questions have come in. But for anyone who has any questions, please use the side menu and ask away. We will try to answer as many questions as possible right now. Otherwise, we will of course contact you personally and continue the engaging discussion. But let me start with the first questions here. How easy is it to access UniPlot? Do we have multiple installation files and license management to be able to use UniPlot? Prashant, I think this one is for you.
Okay, Swapnil, then as I mentioned that UniPlot is embedded into the Virtual Dynamics installation package from 2021 release. So as such, the compatible UniPlot version will be automatically installed. So no separate installation file for UniPlot is necessary. But this will be only limited to Virtual Dynamics and it cannot be opened as a standalone software. So you will not be able to even see UniPlot option if you are not using a UniPlot tool separately. Yes. And with respect to licensing, so UniPlot licensing is part of Virtual Dynamics purchase only, and it uses the same Virtual Dynamics licensing manager. So no separate tool is required for managing the UniPlot tool.
That's correct. Just add to
Okay.
that point, if you're not able to open UniPlot directly from Virtual Dynamics, it means that the necessary license does not exist in your portfolio, and you can always contact us to get it sorted. I will go to the next question. How do you support new users in learning UniPlot? Well, this is a good sign. Someone wants to learn more about UniPlot. How can I learn more about UniPlot usage? Adrian, you want to take this one?
Sorry, I was muted. So regarding UniPlot usage, so first thing before everything, UniPlot documentation. As I said, it's a goldmine of information, but it takes time. So you have several options. First, we have a YouTube channel with several training videos and where we focus on specific topics. So you can go there and learn. And otherwise, we have free training webinar every month for UniPlot. And to know about those, you can follow UniPlot LinkedIn page or Virtual Dynamic LinkedIn page, where we will announce those training webinar. And it's a 1-hour webinar where I personally present advanced UniPlot usage to know everything there is to know.
Great. I think that sums it up. And next question is regarding the measurement results, which is of course very common for engineers. Would it be possible to compare measurement results with simulation results, especially when they're not synchronized in time? I think they mean that measurement results are sometimes minutes long and the simulation results are very short. So would this kind of comparison with UniPlot be possible?
I think I will answer this one. So of course, UniPlot, we didn't talk about that too much today, but it's meant for data comparison. Not only just one file, but you can compare 1, 2, 3, 4 file from simulation, hardware, file a colleague gave you. And then there's a several set of tools to resynchronize those files to properly align them. And even if you want to reinterpolate them at lower or higher frequency, or all of them at the same frequency, even though frequency is never an issue, because unlike other software, UniPlot, if you give it the time channel, it will properly plot the diagram. You do not have to worry about that. So yeah, you can compare measurement and simulation result without any problem.
Great, thank you for that. The next question is, can you read Adams as a dot result file, RES files in UniPlot? I will take this one. Currently, this is not supported. We decided to start with the request files, and incorporating result file also to be compatible with UniPlot is on our roadmap. And next question, let me jump a question from the same person. So can you read measurements in RPC format? Adrian, can you answer on the fly regarding the RPC format?
RPC, I would have to check. Otherwise, if you have a doubt, like I have right now, what I usually do is go to help, content, and I go to search, import data. And here you have the list of data file that is supported in UniPlot. And then you do a little control F RPC, and I do not see anything for the moment. So sorry. There is RPC, the database, but I don't think it's the one we're talking about. And anyway, if you have a doubt, you can share the file with us and we start to work on it. And that's how we usually do with our UniPlot users. Sorry if I cannot answer that right now.
It's okay, we can look into it and maybe talk more about this with the person personally later.
Exactly.
And there are actually a couple of questions regarding the file size limit. And I think I can take this one. There is no limit. You have to imagine that UniPlot has been built up to also work with test bench and calibration results. So the file size can run into tens of GBs, and UniPlot will be able to load them and run with them quite comfortably without any delays. I will move on to one more question. Can one create plots combined from separate simulation runs? The short answer is yes. You can combine as many plots from different simulation runs. And to move on, the second part of the question is, can the sequencer handle import of external data? And I think with what Adrian just showed, it can handle import of external data, and it supports already a huge array of different formats and databases. We are running out of time. Let me take one last question. And for everyone else, if we are not able to answer your question in time today, please be assured we will contact you soon. So the last question is comparison with Adams post processor. So in Adams post processor, we have possibilities of carrying out mathematical operations. I know I personally also use them quite a lot. And what are the different possibilities in UniPlot in comparison for data manipulation? Prashant, you want to take this?
Maybe yes. So as we highlighted during the presentation, me as well as Adrian, this is a powerful tool with many handling possibilities, including filtering, sorting, and also performing complex mathematical functions. You might remember Adrian running a 3-4 line formula for getting the function. So it's easier, so we can manage it.
Okay. Thank you, Prashant. I think that was a lot of engaging discussion for today. And I would thank Prashant and Adrian, both of you, for the wonderful demonstration. For all the participants, I would like to inform you this webinar is recorded, and as usual, you will be able to replay it later here on GoToWebinar or also on the Virtual Dynamics website. Thank you all again for taking part in this FEV webinar today. And thank you, Prashant and Adrian, again for giving everyone a chance to learn more about Virtual Dynamics and UniPlot. Have a nice day, everyone. Thank you. Bye.
Thanks for watching us. For any question, contact us at support@uniplot.com. Come and check our website www.uniplot.com and click on the logo to follow us on LinkedIn and get fresh news of UniPlot.